Alright class, time to get going. Here's the warm-up. Number 1 says to state whether the sentence is always, sometimes, or never true. The three altitudes of a triangle intersect at a point inside the triangle. And so this is a review back to a couple units ago. So three altitudes of a triangle intersect at a point inside the triangle. It depends on the triangle. So this is definitely not always true, but it is also sometimes true. So the answer is sometimes. Now, number 2 is a bit more complicated than that. So it says to find n and list the sides of triangle PQR in order from shortest to longest if the measure of angle P is 12n minus 15, the measure of angle Q is 7n plus 26, and the measure of angle R is 8n minus 47. So first off, to find n, we know that all the angles of a triangle need to sum to be 180. We have what the measures are in terms of n here. So that means that 12n minus 15 plus 7n plus 26 plus 8n minus 47 has to equal 180. So we're going to combine like terms. We got 12n plus 7n plus 8n comes out to be 27n. And negative 15 plus 26 minus 47 comes out to be negative 36, equal to 180. Now we simplify this and solve for n. So we're going to add 36 to both sides. So that gets us 216, hold on. 216 on the right, and 27n still on the left. We divide by 27. 27's cancel. And we're left with n being equal to 8. So now we have what n is. That's half of what we were trying to find. But now we need to know which angle is the biggest, which one. Really, the length of the sides has to do with the angles as well. So the largest angle is going to be the longest side across from it. So same for the others, like the shortest side is going to be the shortest, smallest angle, and the middle side is going to be the middle angle. So we have the measure of angle P is that 12n minus 15. And we're going to plug in 8 here for n. And when we solve that, m, the measure of angle P, comes out to be 81 degrees. Now we got to do that for each of these angles. So we have that Q is 7n plus 26. So we need to do that as well. 7n plus 26. We replace, this is the measure of angle Q. Let me rewrite that. Give myself some space. So the measure of angle Q, 7n plus 26. Again, we replace n with 8. And the measure of angle Q comes out to be 82 degrees. So slightly bigger than the other one. But at this point, we know that, again, triangles, the sums all have to be 180. We have 82 and 81 right now. Even if those were just 80, we'd have 160 degrees. So the other one's going to be less than 20 for sure. It's going to be the smallest angle. So let's go ahead and find out what that is. So the measure of angle R is equal to the 8n minus 47. So the measure of angle R is equal to 8 times 8 minus 47. And when we figure out our answer there, the measure of angle R comes out to be 17 degrees. So Now, all we have to do is put these in order from shortest to longest. So same thing we could do with the angles. R is the smallest angle, so R is going to be the smallest side. So we're going to make the sides be the lowercase versions of these. So it's R, and then P is the middle term, and then Q. So R, P, and Q in that order. Very long for the second warm-up problem, but very informative as well. Let's move on. So our two vocab words for the day, we're doing two sections today, the 6-1 over angles of polygons, and 6-2, which is about parallelograms. So that's why diagonal and parallelogram are our vocab words for the day. So the first thing here, the polygon interior angle sum. Basically what this means is that however many sides, or technically however many angles, because however many sides you have should be the same as the number of angles. So an n-sided convex polygon, so all the angles are pointing out, none pointing in. If you have one pointing in, it's not going to work for this formula. So n-sided polygon has the sum of the interior angles equal to n minus 2, in parentheses, times 180. So for example here they have a pentagon, so 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540. If you need more time, pause it, write this down. Our first example here is to use that formula, and we're going to use that formula on a nonagon. If you don't know what a nonagon is, it has 9 sides. Nonagon, 9. So octagon would be 8, right? Decagon has 10. Anything bigger than that, look it up. So nonagon has 9 sides, so that's our n. And our formula we know is n minus 2 times 180. So that means that 9 minus 2 times 180 is what we're looking at here. And we know that 9 minus 2 is 7 times 180. And using a calculator, unless you know what 7 times 180 is, if you do, props to you, but it is a 1260. And there's our answer. So the sum of the measures of the interior angles of a convex nonagon are 1260 degrees, or is 1260 degrees. Now, if we wanted to, we could divide that by 9 and find out what each angle is if it's a regular nonagon. It doesn't say this is a regular nonagon, so we can't assume that, but that's how you would find that, and we will be doing that in a little bit here. So let's move on. So this one here has a parallelogram given to us. We want to find the measures of each interior angle. If you notice, since it is a parallelogram, we have 2 angles that are the same, and then the other 2 angles are the same. And we know that there's a few laws that we haven't learned just yet. So what we do know, though, is that the sum of all these needs to be equal to 360, right? If you had a parallelogram, or a rectangle, it's technically a parallelogram, it would have 4 90-degree angles, and 4 times 90 is 360. So we're going to add these up and set it equal to 360. And by add these up, I mean we're going to multiply each one by 2, because there are 2 of each of them. So 2 times 11x plus 4 plus 2 times 5x. Make it a little bit shorter for us so we don't have a bunch of stuff to combine together. And that is equal to 360. So now we need to multiply the 2's in here. So 2 times 11x is 22x, and 2 times 4 is 8, plus 2 times 5x is 10x, equal to 360. When we combine like terms now, we got 22x plus 10x is 32x, plus 8 equal to 360. And then we subtract the 8 from both sides. 32x is equal to 352. Then we divide by 32 on both sides. Cancels out the 32 on the left. And our x comes out to be 11. Now, I don't want to block that off because that's not our answer. We're trying to find the actual measures of the angles. So we need to take that 11 and plug it into each one of these. So the first one, so angles T and R are the same. So for the measure of angle T, and that is terrible looking, and the measure of angle R, we're going to use the 5x, right? So that's 5 times 11, which is 55 degrees. And then for the measures of angle S and U, we're going to use the 11x plus 4. Again, plug in the 11. And 11 times 11 is 121, plus 4 gets us 125 degrees. So those are our answers that we're actually looking for in this problem. All right, pause it if you need to. The next problem. Here we have a mall designed so that 5 walkways meet at a food court that is the shape of a regular polygon. So now we need to find the measure of each angle, basically. And since it is a regular polygon, all 5 angles are the same. So our equation that we used before, or the formula, is going to change a little bit. And now we have, it's basically n minus 2 times 180 still. But now all of that divided by 5. Not 5 in this problem, yeah, divided by n. So n is still the number of sides that the shape has. So a pentagon has 5 sides. Obviously we have 5. We can see that in the picture that they gave us. So all we have to do is plug in 5 for n here and simplify. So 5 minus 2 times 180 divided by 5. 5 minus 2 is 3 times 180 divided by 5. 3 times 180 is 540 divided by 5. And that comes out to be, we don't have, let's see, we'll just call this x that we're trying to find. So that means that x is equal to 108 degrees. There's our answer. Again, you need to pause it, rewatch it, do whatever you need to. I know I'm kind of going fast today. Got a lot to get through. So our next problem here, we have to find the measure of the interior, or we are given the measure of the interior angle of a regular polygon, and we want to find the number of sides it is. So we're basically trying to figure out what kind of polygon we are using here. So we can use that same formula, leaving n as n, and setting it equal to the 150 that we're given. So the first thing we're going to do is multiply both sides by n, so we can get rid of the fraction on the left. So we have n minus 2 times 180 equal to 150n. So now we have this n minus 2 times 180. We can distribute the 180 inside the parentheses. So it's 180n minus 2 times 180 is 360 equal to 150n. We can subtract 180n from both sides. We're left with a negative 360 equal to a negative 30n. We divide both sides by negative 30, so the negatives will go away, and it'll be good. And our n comes out to be 12. So this is a 12-sided figure. n is equal to 12, we got 12 sides to this. Now, moving on here, we have a new rule, actually. Alright, so our next thing here is this new theorem that we have not seen. The Polygon exterior angle sum theorem says that the sum of the exterior measures of a convex polygon. One angle at each vertex is 360 degrees. So you can see our shape here. Kind of looks like a Chinese throwing star or something. But basically, no matter however many the angles are, they all need to add to be equal to 360. It's that easy. So let's look at an example. So for our example here, we have to add all of these sides together. So it's a lot, I know. And combine our like terms, set it equal to 360, and solve for x. So that's what we're going to do. So I'm going to set it up a bit different than you normally would, right? Usually with stuff like this, you would set it up horizontally. I'm going to set it up vertically. Horizontally would mean like, all the way across, right? So it'd be 5x plus 5 plus 5x plus 4x minus 6 and so on. But that is very long. For one, we don't have a ton of space here on the screen. So to save space, I'm going to do a vertical addition of this stuff. So we have, starting with the top left there, we got 5x plus 5. 5x. So then we got the 4x minus 6. 5x minus 5. 4x plus 3. 6x minus 12. So I'm just going around the figure clockwise. So we got 2x plus 3, and then we're back to the 5x plus 5 I started with. So now we're going to add. So kind of like old school addition, right? So if we add down the right, if you notice we got a 5 and a negative 5, so those are going to cancel each other out and make it a little easier. We also have a 6 and 2 3s. Those will cancel each other out. And we're just left with a negative 12. So that's super easy. And then we have to add these x's. None of them are negative, so no one's going to cancel here. So we end up with 5 plus 5 is 10, plus 4 is 14, plus 5 is 19, plus 4 is 23, plus 6 is 29, and plus 2 is 31. So we have 31x. So 31x minus 12 is equal to 360. So now we can add 12 to both sides. 31x is equal to 372. And we divide by 31 on both sides. And we end up getting our x equal to 12. All right. A lot of work to get the addition done, but once you got it done, it's not too bad. It's just a simple one variable, two-step problem. All right. So our next one here, we are given that is a decagon. So again, that has 10 sides. We need to find the measure of each exterior angle of a decagon. This is extremely easy. All right. All you have to do is remember that a decagon has 10 sides, so n is 10, and we know that the exterior angles of any polygon all have to add to be 360. So we divide 360 by 10, and we get 36 degrees, and that's it. Super, super easy, right? So try to remember that, all right? If you remember those things, that the exterior angles all add to be 360, and whatever the figure is, you remember how many sides it has. If you're in my class, that yellow poster I have up, I think goes up to at least decagon. So, I mean, you have no excuse to not know what that is. At this point in your life especially, you should probably know up to decagon, but anyway. If anything, you should know what an octagon is, right? It's a stop sign. Right, next problem. Next thing. So we have some properties of parallelograms. So this is getting into our next section, 6.2. We have a few different parallelogram properties here. The first one says that if a quadrilateral is a parallelogram, then its opposite sides are congruent, which is kind of everything we kind of know already about parallelograms. The next one, same idea. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So, same idea, just with the angles. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So that means that x plus y is equal to 180, no matter which way you go. So you can go from the angle M down there up to J. Those two added together are going to be 180. J plus K, 180. K plus L, 180. L plus M, 180. They're all going to be that way. And if a parallelogram has one right angle, then it has four right angles. And it's a special version of a parallelogram known as a rectangle. Alright, so those are your properties. If you need to pause it, take the time to write this stuff down. Writing helps you remember. So here's our first example here in construction. Notice the shape is still in blue. I couldn't change it. It was an image, so sorry. But still write it. In parallelogram ABCD, we need to suppose that the measure of angle B is 82. The length of side CD is 80 inches, and the length of side BC is 15 inches. We need to find the length of side AC. Or AD, sorry. So if we know two of the sides, we know all the sides, right? It's a parallelogram. The sides parallel or opposite of each other are congruent. So this is congruent to that. This is congruent to this. So if we know what BC is, that means that AD, which is across from it, is the same thing. And that means that BC is equal to AB, which is equal to 15 inches. And boom, we're done. No calculation needed, just some knowledge of the properties. All right, now let's look at our next one. Same image. But now we have that, or everything stayed the same. Now we just need to find the measure of angle C. So again, these are just using these properties. We know angle B to be 32 degrees. So if this is 32, and we know that the sides next to each other, or consecutive sides, or consecutive angles are supplementary. So that means they add to be 180. So the measure of angle B plus the measure of angle C has to equal 180. We know the measure of angle B is 32. So now we just need to subtract 32 from 180. So our measure of angle C is 148. And that's it. Next problem. Same image again. Using these properties and everything's the same. Now we need to find the measure of angle D. This is a very easy one again, right? We know that B is congruent to D. We know that A is congruent to C. And if that's the case, then that means that if the measure of angle B is equal to the measure of angle D, then they are both equal to 32 degrees. And there's our answer. Super easy if you know those properties. These are properties you should have known, really. I mean, I think 7th grade is a common geometry-based math. We have some diagonals theorems with parallelograms. So the diagonal is what goes across the parallelogram to the opposite corners, or opposite vertices. So if a quadrilateral is a parallelogram, then its diagonals bisect each other. So what that means, it doesn't really show you in the image. I will write on the image here to show you what it's saying. But if ABCD is a parallelogram, then AP is congruent to PC, and DP is congruent to PB. So if we look at our image here, that means that AP here, with our 3 tick marks, is congruent to PC, and DP is congruent to DB, with 4 tick marks. Lots of congruency going on here, right? And that's going to help you out a lot in some of these problems we're going to do in a minute, okay? The next one just means that these triangles are congruent. Same exact triangle. If you flipped it around, it's like a mirror image plus a rotation too. All right? So our first example with this, we need to find R, and you can see there's a lot going on. R, S, and T are all in there, and we're going to find all 3, but right now we're just finding R. So for R is the side WX, and it's a side of the parallelogram, and ZY is the other side of our parallelogram, and we know ZY is 18. So that means that WX being 4Y, or 4R, is equal to ZY, which is 18. So we divide both sides by 4. R is equal to 18 divided by 4 is 4.5. There's our R. That's a terrible looking R. There you go, a little better. Pardon my handwriting. It's not great on paper either. All right, so next problem. Now we're going to find either S or T. I think it's S next. It is S next. All right. So for S, we have that's that segment from Z to the midpoint, right? Or the middle of that diagonal. And remember, when we have 2 diagonals, they bisect each other, right? So that means that 8S has to be equal to 7S plus 3. There's our equation. Solve for S, right? So 8S equal to 7S plus 3. We subtract 7S from both sides. Cancels on the right. And 8 minus 7 is just S now, equal to 3. Done. Boom. Simple. Okay, so now we've already found R and S. Time to find T. So here, for T, is an angle in there, right? And I'm going to draw these out so you can kind of see what I'm talking about. But remember our triangles, right? The second property we just looked at. Change color here. Pick blue. Can't pick blue. They're already blue. So you can see our 2 triangles there, right? And the very top, or not the top, but like the leftmost, I guess, for the top triangle is that one vertex that is congruent to the other vertex. So that means that this angle here is the same as this angle here. So 2T is equal to 18 degrees. And so it's basically exactly as simple as the first one for R was. So we just divide by 2 on both sides. 18 divided by 2 is 9. Boom, done. Again, super, super easy. You just got to be able to pull stuff out from the image, okay? That's the key. But again, if you know these properties and these theorems, it's super easy, guys. You just need to memorize those things, all right? I know it sounds difficult, especially if you're in Miss Ween's class, all right? Please pay attention to the video. Turn around, pay attention, stop talking. If you guys watch these videos, I promise you, it's going to help you. Watch them over and over again. I know they're long. I'm sorry they're long. But right now, without a teacher, you got to take your education into your own hands. And, I mean, me and Mr. Navarrete are doing everything we can to help you out, but you got to help yourself too, you know. So, this is our last example before our exit ticket. This is definitely our most complicated example. So, I'm going to set up a coordinate system here. Or actually, let me see. I should have taken an image of one. And I would use, there's actually a way to put a grid on here, but the issue is that the grid I would want to put is it gets washed out when you project it, so it doesn't work very well. Hopefully the grid I'm about to use works, so there you go, there's our grid. So let's actually use some of these specific lines here inside of our grid. It's not super even, but that's okay. Just notice that it's like an odd numbered graph. Well, that's all right. So let's plot these points. Point M is at -3, 0. So that's on our vertex here, right here. There's M. And N is at -1, 3. It's up there. P is at 5, 4. And R is at 3, 1. I don't know why it won't let me draw the dot here right now. There we go. I'm going to try to get rid of this extra dot here. There we go. So that is R. So now we just need to connect our points together. And we'll have our parallelogram. There it is. So now, first thing we need to do is go ahead and set up our diagonals, because it does say we're trying to find the intersection of the diagonals. So I'm going to color the diagonals in green. So since I perfectly drew this, we can see it, right? Now, you're not going to probably perfectly draw this, right? If you are, that's great. But, and even then, you can see mine's off a little bit. Now, so, like I said, my point's not perfect, right? And unless you're like, I mean, I have this tool that can do this perfect graphing like this, unless you are like a computer when it comes to graphing, which I can probably tell most of you won't. Probably not, that's okay. We have to use that property we just looked at, right? We know that the midpoints, or the diagonals, sorry, are bisecting each other, right? So that means that without even making that purple point I just made, we know that, using blue here, these two sides are equal, right? And these two are equal. I just showed you that on one of the last theorems we had. And that means that the point right in the middle is the midpoint for either of those two lines. So if we use the midpoint formula, we can find the midpoint for line NR or the midpoint for line PM. You got two options. I'm going to show you both just to show you that I get the exact same thing no matter what, okay? So, midpoint for PM. Didn't mean to do blue. PM, right? So if you remember the midpoint formula, I'll write it off to the left here. That's going to be x1 plus x2 over 2, and y1 plus y2 over 2. That's your midpoint formula. Hopefully you guys remember that. Now, all we need to do is our midpoint for line PM. So we know that point P is at 5, 4, right? So our x is 5, the y is 4. And we're going to add our y values and divide by 2. So the y value for, or not the y value, sorry, we're going to add in our values for m. So the x value for m is -3, and the y value for m is 0. So 5 plus -3 is 5 minus 3, which is 2, and 2 divided by 2 is 1. 4 plus 0 is 4, and 4 divided by 2 is 2. There's our coordinates, which if you look on the graph is pretty close to where mine is. And I mean, I made this using this nice tool that I have, right? So again, unless you have like the most immaculate or ideal graphing skills, this is the way to go. Okay, now that's for PM. Let's do the same thing for NR, and basically we can use this as a check because this should be the exact same thing. All right, so all our fractions over 2. N is at -1, 3. So -1, 3. And R is at 3, 1. So we're going to add 3 here, add 1 here. -1 plus 3 is 2, and 2 over 1, or 2 over 2 is 1. 3 plus 1 is 4, and 4 divided by 2 is 2. Look at that. We got our 1 over 2, so that checks. Pretty cool, right? So 3 different ways you could have done this. Drawing a picture, even if you didn't graph it, of how it looks, helps you out a lot, okay? And even looking at just the placement of the letters here, we got M, N, P, R, right? That's the parallelogram's name. So that means that MP is going to be the 2 corners across from each other, and NR will be across from each other, because they're every other letter in the name. You're going around the parallelogram to make the name. So that means that those have to be across from each other. Use those points in the midpoint formula, and you're done. It's pretty cool, right? I thought it was pretty cool when I was going through this for the first time. Again, I haven't taught geometry before, so this is like a refresher course for me too when I'm starting to do this stuff. Especially when I'm doing these videos now. I'm kind of getting some pre-knowledge done right before I get to teach it. So with that said, here is your exit ticket. Alright, find X, and we'll see you next time.